Almost there, come on! How far are they?
About a fifth of a light year.
What? Yup, or around 13,000 astronomical units. You guys should have just took the flare.
Of course, a planet that's cold and possibly gaseous would never understand.
Y'all should have ran when Proxima A was at its perihelion, not aphelion.
Then how are we supposed to know?
When the binary system looks larger, not small. Stop arguing! He's coming closer!
Oh.
Whoa!
Hug! You three, get back here! Brought some asteroids from the asteroid belt.
B. Proxima A is a star. The asteroids won't do anything.
Oh. Are you okay after you got flared?
Get bombarded with stellar radiation all the time. Oh my!
Not three at once!
Ugh! Whoa! How long is this gonna last for?
He's using a strong gravity to pull us back.
Oh, my insides can't. Handle the tidal heating.
You monster.
I can't move. No, Proxima C! Go to Alpha Centauri A. He's the biggest one here, Whoa! No!
Just run!
How fast are we going?
Hey, there's absolutely no time to explain anything right now.
Okay, I'll keep my mouth shut. Wait, we're at the point where the gravity of both stars is becoming noticeable.
Get ready. 1, 2, 3.
Whee! No way! We're finally at Alpha Centauri A!
Yeah, sure.
Huh? Why are you guys here?
To basically get a break from flaring?
Oh, I know you. You're the one that everyone thought was habitable.
And see how that turned out.
Hey, just be careful of that large gas giant in my habitable zone. If you want to be habitable.
Sure.
Gee, this place is really big.
Yeah, I'm used to orbiting close to stars. Watch it! Rigel Cantorus B.
Long time no see, I guess.
Anyway, why are you two here? Shouldn't you guys be with your star Alpha Centauri C? To basically get a break from flaring? Oh, come on. Orbiting a red dwarf isn't that bad. Yes, it is. The flares and XUV radiation strip away the atmospheres of red dwarf planet and tidally lock them, leaving one side hot and one side cold, making terrestrial planets like us uninhabitable.
You're not even understanding what we live through. All stars do that. And look, I'm even flaring right now.
Did you guys forget that subsurface oceans exist? Wait, what do you mean? If a planet with a subsurface ocean receives a good amount of tidal heating, it could allow for hydrothermal vents to form and allow life to form as well. And the only thing stopping it from having life is its size. If it's too small, then it won't differentiate. If it's too big, then the bottom layers would become solid, locking away hydrothermal vents.
Okay, what about Earth-like planets in the habitable zone of their star? Like oceans and atmospheres.
Those could even exist too. What? There's absolutely no way that's actually possible. Well, it's true, but let's first get to the atmospheres part.
So, how do you get an atmosphere?
Well, first, it has to be big enough because big planets have higher escape velocities, and the gas will stay put if it doesn't reach the escape velocity. And cold planets can have atmospheres too, as the gas particles move slower, making it stay put. In fact, there are some examples of red dwarf planets having atmospheres too, OHS 1140b and L9859d.
Is a magnetic field necessary for an atmosphere?
Well, no, just look at the solar system. What about the XUV radiation and flares? That's just one depending factor on if a planet has an atmosphere or not.
What about being tidally locked?
Though if we assume some things, then tidally locked planets can also be habitable. Planetary atmospheres and oceans can also transfer heat around, making survivable temperatures on both sides. And here's some random information. Planets on the inner edge of the habitable zone would get a permanent cloud layer reflecting the most harmful rays, preventing a greenhouse effect. Though this cloud layer would not form on the outer edge, allowing for direct sunlight to hit the planet's surface and preventing global freeze-over. What about the tidal forces? It would cause volcanic activity and also drag continents to the substellar point. And plate tectonics are good for the long term, as they store and release carbon atoms.
And water?
Well, red dwarf planets form extremely dry, so extremely large impacts carrying water would form oceans. Combined with tidal heating, could form hydrothermal vents, allowing for life to form. Though red dwarfs emit mostly infrared light, which doesn't have enough energy to sustain life. Well, that is true. There is some cyanobacteria that utilizes infrared light for photosynthesis. Anyway, time to go back to your star.
But we like the calmness around Alpha Centauri A.
Well, too bad.
Wait, no, stop.
Goodbye.